Hello. I want to show you another part of my NPC experiments, which I think might be the most interesting part, even though it's not as complex as the collision avoidance, which is the state system that lets NPCs do more than one thing in sequence and, switch between what they're doing. So you probably noticed that I no longer have the uh, little primitive based test model for the NPC, and that's because I have actual models created by Ultrayanto as part of our entry for the Metaverse Maker competition, which is now wrapping up one day from now. And we're not done yet, but we'll get there. So let me just attach you to one of these NPCs so you could watch what they do for a little while and see how their behavior works, and then I'll open up the logics and show you how I implemented that. So this guy has dropped off his wood and he is looking for a new tree to go chop down. I honestly don't know what tree he's headed towards, although it looks to be fairly high up the hill here. So he's currently in the walking to tree state.
Chopping wood.
And he found a tree. Well, you are in exactly the position where you can't see him, but he has switched to the chopping tree state, obviously with associated animation. And now he's in the walking back home state, carrying the log there. And we have collision detection turned off for all of these trees and rocks because we didn't want them to have trouble walking through the woods. Like I said, the entry is not quite done yet. Looks like he didn't quite make that turn between the buildings, so he's probably going to walk all the way around the end here. Sorry for the wobbly camera, that's just an effect of the collision avoidance system. And he dropped off his wood, so he's back to the finding another tree to chop down state. Okay, I turned on the debug state and made this guy stop walking for a minute so we can inspect the logics on him. So the way these NPCs do different tasks is just a very simple state system. And they each only have 3 states. And the state system itself only has 2 functions. It has a change state and an update state. So all this NPC does is it changes between a state that is, well, let's say that this is a wood chopper, although I think this one was actually getting stone. But he walks to tree, chops tree, walks to wood pile, and goes back to walk to tree. It just cycles through those 3 states. And the way that I set up the states, I mean, there's probably a million ways you could do this, but each state has 3 functions: an enter state that is executed when you first start the particular state, a leave state that executes when the state is being left, exiting, being done with, and an update state that executes once on update tick, which is currently set to 15 times a second. And the way it works is the state system looks for these slots by name, so you don't have to hook up any logics when you make a new state. You just copy one of the existing ones and change the name. When you tell it to enter that state, it does enter state. During the update loop, it calls update state for only the currently selected state and no other. And when it's done, it calls leave state. The states are actually stored in a dynamic variable, which is just called current state name. So this NPC is currently in the state called stop. So if we look at, say, the change state function, this is the function that you call whenever you wish to change from one state to another. Apparently some parts are going to come in huge because I'm currently down at 1/10 scale. So I had a bug which I haven't been able to work out, and just did a really stupid thing where I have a timeout here that once you change a state, it resets the time and state, and it doesn't let you change state until you've been in that state for 1 second. So I was having some order of operation issues where I would change into a state and the NPC would think it was at its destination of the new state, even though the destination had changed, and it would just immediately skip over a state. So this is to work around a bug that I haven't fixed. But what it does is when you do change state, dynamic impulse receiver with string, it gets the current state slot by doing a find child by name based on the current state name dynamic variable. It calls the leave state function only for that state because it's targeted, the dynamic impulse is targeted to that slot only. After that, it writes the current state name into the dynamic variable, changing what your current state is. And then finally it calls enter state for the new state that you have just written into the dynamic variable. I'm sorry, I cannot talk tonight. So it's really quite simple. Change state is just leave state, save do state name, enter new state. Not much to it. And of course, update state is even simpler. Again, this timed part up here is just to work around a stupid bug that I haven't had time to debug properly. So on update, it calls the dynamic impulse update state, and it targets it only to the slot of the current state based on the name. So it doesn't call update for all the states, it calls update only for the current state. And we'll look at some states for the woodcutter just to see what kind of things you might do in your your 3 enter, leave, and update functions. So if you start walking to a tree, when you enter the walking to tree state, all he does is he says find resource trees, which is just a dynamic impulse receiver that it knows where the list of all the trees in the world is. It picks one at random and sets that as its current target. So find a tree. This is writing to a variable called walking to tell the whole walking system that we covered in earlier experiments to start moving forwards. And finally, it writes a dynamic variable called play animation of type walking to tell the NPC to play the walking animation. So all he does is find a tree and set that as his target, start walking, and play the walking animation. Now when you're in the middle of the walk to tree state, this will execute currently 15 times a second, or whatever your update rate is set to. He says if my target has been reached by looking at another dynamic variable, which is comparing the NPC's position to the target position and saying, am I close enough to count as having hit the target? So if I'm at the target, then we'd go down to this one and says, is the target harvestable? So this is like if the tree has been cut down already, it'll return false. If the tree is fully grown, it will return true. So if the tree is available to be harvested, we change state to chop tree. Otherwise, we change state to walk to woodpile, and we just walk back home. So the walk to tree update state function has the code that checks to see if we should exit this state. I hope that makes sense. And leave state. All that does is say stop walking. So when we get to the tree, stop walking. And from walk to tree, if the tree was harvestable, we would go to the chop tree state. And when we enter that state, it plays one of two different sounds to start with. This bit of logics here is to make the range of the sound scale with the NPC scale, because I found that when you do a play one shot or the regular play either, the range that the sound is audible from does not respect the scale of the slot it's under, so this was necessary so that they didn't sound like they were shouting really loudly at small scales. So first, play a sound, play the woodcutting animation, and I got really lazy here. I did not use the update state function at all to figure out when the state should leave, but in the enter state function I just did a delayed impulse that said after tree chop duration, which I think is 12 seconds, we tell the tree to die, so you tell the tree to fall over, and we change state walk to woodpile. So really there is no update for the chop tree because the enter state also decides when you leave the state. There's nothing to check in the update. I will unpack that just to verify. So yes, update state for chop tree does nothing. Whoa, that's a big relay. If we look at leave state for chop tree, what this does is it says we write a dynamic variable called resource inventory with the value of wood to say that we have wood in our inventory. So we've chopped the tree, there's wood in our NPC's inventory. And the last state was walk back to the woodpile. So when you start walking to the woodpile, the first thing you do is find place woodpiles. This will look at the list of all of the woodpiles in the world and choose one at random and set that as the NPC's target for its walking system to go towards. We write walking as true, or we write a true to walking to tell the NPC to start walking forwards. And we play animation walking. Nothing complicated, just find a woodpile, start walking forwards, and play the walking animation. Now, during the walk to woodpile state, when you update it, which is 15 times a second or whatever you set the update rate to, it says if the target has been reached. So again, if the NPC was close enough to the woodpile to trigger this target reached variable, then we change state to walk to tree. So we go right back to the beginning where it finds a tree and walks to it. And the leave state. So when we are done walking to the woodpile, we set the walking forward to false. We stop walking. And we say resource and inventory none. So he is dropping the wood off at the woodpile. He no longer has any resource in his inventory. And that's all it takes to make this NPC behavior of pick a tree, walk to it, cut it down, bring it back to the woodpile, and repeat. It's just those three states working together, changing from one state to the other with the enter state, leave state, and update state functions. It's really not much to it, but it makes interesting behaviors. I guess I could show you that on the NPC model, the props folder has that's the stuff like the axe, the pickaxe, the log he carries on his shoulder, and the stone he carries on his back. And I could have written those on and off in the state system, but instead I just did a thing here that says based on the dynamic variable resource in inventory, we either show or hide the wood, and we show or hide the stone. So that's just writing to the active property of that slot. And for the pickaxe and the axe, it's a little more complicated because we wanted these to animate growing big and growing small. So we look at the variable current state name, what state is he in. If he is chopping the tree, we set the scale of the axe to 0.82. If he isn't chopping the tree, we set the scale of the axe to 0.01. Likewise for the pickaxe and the state called mine rock. And then there's a smooth transform on the actual axe and pickaxe models so that they scale smoothly instead of jumping to 0.82 size or 2.01 size. So that's just another way if you don't want to write things in the state functions, you can just look at the current state and turn things on and off based on the current state, or look at what he has in his inventory, which was written by the states, and turn that on and off. I hope that makes some sense. There really is not much to it. State machines are a pretty simple thing when you come down to it. And they're not really too hard to do in Neos either once you realize that you can target dynamic impulses to specific slots. It's pretty easy to make a very simple state machine, but it obviously enables pretty interesting behaviors. So perhaps this will be useful to someone who needs to do something similar. But come check out this world, which is, I don't even know what we're naming it yet, but it's going to be an entry for the MMC competition, whatever you call it. So that's all. Goodbye.